Okay, you said number 9?
Sorry, I didn't
I
get
did.
it, and I
Okay,
realized
find an expression. Oh yeah, okay. So you know for number 9 that the general
So
formula is
main
this, right? Uh-huh. And then they're giving you 3 points.
this is equal.
you get
So I'm going to plug in 1 for x,
you get part
okay?
of that.
And then set that equal to 6. So if I plug in 1 for
Okay.
x, I get a
I'm not
plus
up to
b
that.
plus c plus d equals 6. And then if I plug in negative 1 for x, all of these are going to equal 0 apparently. So if I plug in negative 1 for x, negative 1 cubed is negative 1. So that'll be negative a. Negative 1 squared is 1, so that'll be positive b. Negative 1 times c is negative c, and then plus b equals 0. And then if I plug in 0, that's easy. All of these are gone. So what they just told me is that b equals 0. So that's going to make my life easier in a minute. Hold on a second. And then if I plug in 2 to all of these, I get 8a plus 4b plus 2c plus d equals 0. Yeah. Good.
And the B is gone.
Right. Because I always do it. Yeah, yeah.
So you can just erase these ones and do zero.
Yeah, good. So we can get rid of all of the b's because b equals 0. So now I have 3 equations and 3 variables. So do you want to solve that algebraically just for fun? Okay. No. It's pretty easy because what do you notice about the first 2 equations? What, the a's cancel and the c's cancel. So if I add those together, then 2b equals 6, and so b equals 3. So we've so far figured out 2 of the 4 variables. Okay, now I'm going to plug 3 in for b's into, I don't know, the top one and the bottom one. So if I plug it into the top one, I get a plus c equals 3. And if I plug it into the bottom one, then I get 8a plus 2c equals negative 12. No, because there was already a 6 here, so I'm going to plug the 3 and then subtract 6 minus 3 is still 3. What do you want to multiply the top by to get something to cancel on the bottom? Negative 2. Okay, so that'll rewrite it as negative 2a minus 2c equals negative 6. And then I still have 8a plus 2c equals negative 12. 6a equals negative 18. So a equals negative 3. So that's the third. So now I just need c. So let's put it in the very top one. Okay, so if I put that into there, then negative 3 plus 3, those cancel. Yeah, so c equals 1. And then my equation is y equals negative 3xc plus 3x squared plus 6x. No, that's fine. That's number 9. What was it again? Yeah.
I was done for 11,
11?
15. 11, 15, and 17.
11, 15, and 17. 11. Alright, if the recommended adult dosage for a drug is D,
I like B.
I hate these.
then to determine the appropriate dosage C for a
I hate
child
them as well.
of age A, pharmacist use the equation C equals blah, blah, blah. Suppose the dosage for the adult is 200 milligrams. So what did they just tell us? Yep, they just told us that D equals 200. So C is equal to 0.0417 times 200 times A plus 1. See what I did there? Hold on, let me make
Yeah,
sure
so you
Logan.
just plug in the
Yeah, just plug this D back into the adult dosage. Okay, so then Brooke is going to multiply this all out for us. 8.34a plus 8.34. And that's if you multiply these together, you get 8.34 and then the city is
Yep.
up there. Okay, so that means the slope is 8.34. Yeah, what does that represent? Right, good. That's it. Right. So every year that the child grows So how old is a newborn?
But,
0.
so you plug in
Which is
zero
weird,
for
we
Ed?
have stuff the other day, they're not household.
That depends on the year. Beliefs. That's a totally different matter. Usually when you,
So that,
yeah, so for
so it's the
B,
same as
we
adult.
just plugged in the age was 0, okay? So 8.340 plus, that would just work out to be 8.34.
Alright.
No, not that.
Yes, you did,
Very,
it was
very,
easy to prove
very
it.
serious. I never do anything off that. Okay, where am I going now?
I need
15.
15. 15 and 21. Okay, 15. Biologists
And then
have
15.
noticed that the chirping rate, this is a true story by the way, the chirping rate of crickets of a certain species is related to temperature. So you can estimate the temperature by counting the number of chirps that crickets
That's
make
really
per
cool.
minute. Okay? And the relationship appears to be very nearly linear. This is a true story. A cricket produces 113 chirps per minute at 70 degrees Fahrenheit and 173 chirps per minute at 80 degrees Fahrenheit. Okay? So A, find a linear equation that models the temperature T as a function of the number of chirps per minute n. Okay? So the first thing we need is the slope. So by how many chirps per minute is it going up?
So I had a question. So at first, I went zero, or, well, at first I did the X gave me the degrees because I was doing minutes, but then the answer was wrong, so I had to switch it. So I had to go 113, 70 for the points, because I needed another point. You know what I'm saying? So like,
Yeah.
I don't get why that had to be, because it isn't actually the infinite variable, it's temperature.
Okay, when it says find a linear equation that models the temperature T as a function of the number of chirps n, then it's saying yeah that this is the n is the x and T is the y.
But like, but temperature is, I know, I did it right eventually.
Temperature is usually the independent
But
variable.
the question is,
Right, exactly. Okay, so the slope is 6 because the number of chirps per minute is going up by 6. Oh no, she's right because temperature is y and the number of chirps per minute is x. So how does that upside down? Yeah, you're right. So it should be 1/6 of a degree that it goes up, temperature goes up per 100 chirps. And chirps is one of those words that if you write it a lot and say it a lot, it's really, really weird. So then how do we figure out the rest of the equation? Okay, so you did point. You know, y minus, and again, the temperatures are our y's, so did you use 70 or 80? Okay, so y minus 70 equals 1/6 times x minus 113, right? So if I distribute the 1/6, I get y minus 70 equals 1/6 x minus, what's 113 divided by 6? A little bit less than
18.83.
18 point what?
Yeah.
0.83 repeating. And then add 70 to both sides, so you go plus 70 on that. So y equals 1/6 x plus, no, because this is negative, that's probably going to be like 61
Plus
point. No, because
Oh.
okay, so there's the equation. Okay? Okay, B, what is the slope of the graph? 1/6. What does this number represent? This is weird because of the way they're doing it. The slope, the 1/6. The number of degrees that you have to go up to get one more chirp per minute. Yeah. Which, I don't know how you want to look at that. Okay, C, if the crickets are chirping at 106 chirps per minute, estimate the temperature. So you plug that in for, yeah, for x. And then solve that. the ocean, the water pressure is the same as the air pressure above the water, 15 pounds per square inch, because they're in equilibrium. Below the surface, the water pressure increases by 4.34 pounds per square inch for every 10 feet of descent. So they express the water function as the pressure of the function of the depth. So that means the water function is going to be y, and the depth is going to be x. Okay? So the slope is the water pressure increases by 4.34 for every 10 feet of descent. You want to make sure we're not going to get that negative. So that is the slope of 0.34.
As it got deeper, it got more positive.
Right.
4.24?
Says 4.34.
Oh, okay.
Okay. And then we know that the y-intercept is 15. How come? Is that the depth of 0? Yeah. So that means our equation is y equals 0.434x plus 16. Yeah, and then for b, since it says our depth, and the depth is the x, that means our whole equals 20x. Wait. Oh, but it's higher than this is less than 25. So it's
Alright.
what is it? What is it? 195?
It's 196 if you use the
Yeah, I went the wrong way. I thought we were going to be less. Okay, does that make sense, Logan?
Sure.
I just wanted to fact that more than that. So that I was talking about football.
No, I'm not about it at all.
I don't know.
I just don't get it.
Okay.
Well, but even when basketball went state, remember in 2012 when football went state, we had
Might as well just cancel everything else. Okay, so you guys ready for 21? Jake, are you ready?
No.
Are you ready? Are you ready, my dad? Okay. So for 21,
This
can
is
we
not
do
for a problem.
income in the thousands? So we don't have to type all the zeros?
Yeah.
Okay, so that's from 4.
Do the stat. Edit.
No, you have to use both. Yeah, so that. Edit.
So we're doing the income as the L1.
Figure out whatever is there. Yeah, so we're doing 21. So we're going to put the incomes in thousands into L1. Okay? 4. That's it? Okay? Okay, so if I turn on that clock, zoom around, and then the bar graph which represents the
This Arthur value should be very good.
yeah, that one number was yeah. Oh, so it's not
Weird.
Whose goes down too?
I'm done.
Mine goes down.
Are you supposed to put
There you go.
Are you supposed to say like Y1 or anything?
Did I, yeah, you know, oh, yeah, I have L2 versus L2.
For what?
Wait, how does it work? Or is it linear?
Hold on a second, I have to get this right.
So I have to do
got that?
Yeah.
Okay, sorry about
You
that.
get like 9.9.
So, what do you think?
It's pretty low.
It's pretty limited,
Oh
right?
no, that's
Um,
right, I got
alright, let's have the calculator do the work for us, shall we?
Yeah.
Okay, you guys know how to do that?
Got
Okay,
it.
so you hit that button again. So this time we're going to go over to the top menu. And you chose linear, so I'm gonna go with number 4. It says AX plus B. This one you might have different steps depending on what operating system you have on your calculator. You might just hit enter or you go down to calculate and then
You didn't do why you wanted to. Yeah, I got that answer now.
Okay, so y equals negative 0.099.
I got negative 9.97 times 10 to the
I
I got
got
that.
that. I got negative 0.099.
Yeah, so how do we
Well, but the thing is we inputted it without the 4,000. Oh, is that for the
Yeah, so ours are a little bit
Okay.
different than yours. Also
Yeah.
rate? That's what we're doing? Let's see.
That's awful, like,
Find and graph
what?
rate and amount. Oh, they want us to specifically use the first and last graph.
Yeah.
So,
I'm having problems with
okay,
this.
so let's do the first one. Let's just do it the right way. It's not too hard. So this and then this. I guess they're saying that the more money you make, the less stress you have, so the less likely you are to
Oh,
have
makes
stress.
sense.
Okay.
That's okay.
So the slope here is 5.9 over negative 56. And what is that? Well, it's going to be close to 0.1, a little bit. What?
Oh.
Okay. And then which point do you want to use for our control? Point 1, 5, 86, use Did you do that right?
Good. Oh, 7, right?
Yeah, 0.43. Did I do that right? Is that what you got, Mackenzie? Good.
Well, I got something different for these.
Oh,
Yeah, I'm gonna.
okay, C, find
doesn't
and
even-
graph the least squares regression line. So that is this thing right here. Okay, this is the least squares regression line. When you have the calculator do it, that's what that's called. What that means is, I'll show you in a second. So, first of all, since you have to graph this, I'm going to redo this. So I'm going to go second, nope, I'm going to go, stat, thank you, south, and then number 4. And this time before I put,
Wait, what was the equation you got with them?
I'll show you in a second. This time instead of, before I put, calculator, I'm going to have this switch into, yeah. Yeah, alpha before I put the underline. Okay, so now when it comes up with the equation, do you want this equation or
That
the
was
one?
the one that I.
Now it comes up with the equation that we did before, but it also takes that into y equals. And so now when I hit do this, now when I hit graph, it will not only show the scatter plot, but it will show the
Cause I wrote that equation down
for your
equation
right, yeah.
instead of.
Okay, what it means by the least squares, Caleb, is what they do statistically for this is for every point here they draw a line to the regression line and they use that to be the diagonal of a square. Yeah, and then they add up the area of all these squares and they try to make that area be as small as possible. That's what least squares do. Okay? Okay, so what did you come up with then for the regression line equation? Y equals
I used the big numbers.
what What did you guys that just wrote down off the calculator, what did you write down? Yeah, negative point zero what? D, use the linear model in part C to estimate the ultra rate for an income of 25,000. So for us, what do we plug in for F? 25, because we went by 1,000. What did you get?
11.455.
11.455. Okay. Okay, E, according to the model, alright, because those are all for one digit. I'll just write for one digit. Do a copy. According to the model, how likely is it with someone with an income of 80,000 to suffer from septic ulcers? So then we put in 80.
It said how likely, it didn't say what the
But
number was.
that's what we're able to figure out using this model.
Right.
So if you plug in 80, what do you get? It does in the book. Oh, when you type it in. What do you get when you plug in 80? Okay,
Did
so
we take
5
the
point.
1.5?
No, because that's per, this is the Y. It's this
Oh,
one.
that's the wild card.
5 point what, 96?
5.966.
Okay, so that means 5.96 out of 100 means you have about a 6% chance.
Carrying.
And then for F, do you think it would be reasonable to apply the model to someone with an income of $200,000? I want you to say no, because $200,000 is way outside of this group of data, and so things start to maybe swing a little bit.
That's what the negative, negative.
Right, so that would, yeah.
It would, that's.
Yeah, well, that might be true. When you make $200,000 and you're a lot of people around that, and you're using other people also. Maybe that's right to check the top and tell them that. We good? That was not spot on. That was really bad. So in this section, we start with the basic functions we discussed in section 1.2 and then creating new functions by shifting, stretching, and reflecting in a graph. So this is kind of a review of transformations of functions, and hopefully we'll look at it and go, oh yeah, I totally get that. I totally remember that stuff. Okay, so this is all you need to know right here. Write this down if you don't remember, but if you do remember it, you guys don't need to write it down. If you take a function and you add a number onto it, what does it do in the graph? Moves it up. If you take a function and you subtract a number, it makes it go down. If you take a function and subtract a number from the x's inside the parentheses, then it goes to the right because inside the parentheses is always opposite. And if you add a number, then it goes to the left. Okay? So up, down, outside the parentheses, left, right. Right. So now let's consider stretching and reflecting. So if it's outside the parentheses, it's always an up down kind of thing. Okay, so if you take the entire function and multiply it by a number outside that function, then that's going to be a vertical stretch by that certain factor. Okay? If you do it inside the parentheses, then the way they are talking about it is vertically, but I don't want to have you guys think about this or this. Okay? I want you to just think about that if you're multiplying it by the outside, then it's going to be a vertical stretch. If you multiply it inside, remember inside is always opposite. So if you multiply it by, if you put a 3 instead of, or if you put like a 3x in instead of an x, you might think that it would be a horizontal stretch of 3, but it's the opposite, it's going to be a compression of 3. Okay? And then again, negative on the outside, all it is an up down thing, so that flips it over the x-axis because it's on the outside. Negative on the inside is the right thing, so that will flip over the y-axis. Okay? Okay, so for example, if you were given the graph of y equals the square root of x, use transformations to graph y equals square root of x minus 2, square root of x minus 2, negative square root of x, 2 square root of x, and negative root of x. Okay? Yeah, you can just watch, listen, and learn. We do have a chapter 1 test when we're done with this chapter. We're getting close. Only 4. Or you can do a practice test just this one because it's your first one in this new class. You can do a practice test. No, you did this one. You don't do those. Okay, so those are the points for the square root of x. Okay? Square root of x minus 2, what do you do with all those points? Down 2. Okay, so the square root of x minus 2 would be here. So this would be the graph of the square root of x minus 2. Well, let's not worry about that right now. Square root of x minus 2, this time the minus 2 is inside the parentheses. What does it do to all these points? Right 2. Here, 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 here. So this beautiful line green graph is the square root of x minus 2. How about negative square root of x? Flip them all over because these are all y coordinates that become negative y coordinates. So 0 stays at 0, but 1 becomes negative 1, 2 becomes negative 2, or 3 becomes negative 3. So negative square root of x. Okay, a stretch for you. The 2 out in front takes all of these y values and doubles them. Okay? So this times 2 is still 0, but this times 2 is 2. This times 2 is 4, and this times 2 is 6. So it's a stretchy graph. Okay, and then the negative x on the inside takes this and makes it, no, it's going to flip it this way. Yeah, because if I try to plug in 1, I'd be putting the square root of negative 1, which I can't. But to plug in negative 1 instead, which changes that to positive 1, and then I can take the square root of that. So it's reflected across the y-axis. That's the first one. Okay, how would you... So Google was like, on the day of your birth. That's a good trivia thing for you to say to yeah, give me a fun fact when people start talking about your birthday and you're clearly embarrassed about that, then you can shift the focus to Google. You can just go, hey, you know who else's birthday is today? Okay, sketch graph of function x squared plus 6x plus 10. How? Kinda. No. You know that the y-intercept is going to be up 10 because of the plus 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, you know it's going to be a parabola.
When you move that x-axis down, so we can
see that nicely pointed.
y is essentially
okay, the way you graph a crazy thing like this, you're not going to like this very much, but I'm going to do it anyway, is you can take the square, you need to get it into vertex square. Okay? So I'm going to go x squared plus 6x plus 9, because I cut the 6 in half, got 3, squared it, got 9, and then I still have the plus 10 and then minus 9. And this plus 9 and this minus 9 have to balance each other out. Because it's a y equals, it's not equal to 0. I'm not solving the equation, I'm trying to graph it. And that's the confusing part of doing it this way. So then this factors into x plus 3 squared plus 1. So there you know where the vertex is now. Negative 3, 1. right here.
Gotcha.
Where possible
So
I
that
act it.
is opposite.
And then, yeah, you know that it's gonna be symmetrical, the axis is going to is right down the middle. So that means there's another point over here.
So 1 point is -3 because it's +3.
Right.
And
like
then
that.
the 1 is in 1. Okay.
Does it?
That's not that crazy.
Oh, okay. I thought this thing was gonna give people together.
No, I just, the all I can do is that you just put the left side, so you're not gonna touch this one.
Alright, perhaps we have time for one more. Didn't we graph on a T-Rex already in the review thing or diagnostic thing? Okay, do you wanna sketch these graphs? How do you feel about these? I'm not saying do you want to, because of course you don't want to, because you're doing math, but do you feel like you need to practice these?
kind of- Oh, because they're fine graphs. I would say yes. No, I don't know, sorry,
That's fine.
Can I grab a piece of graphic?
Yeah, you bet, please. Yeah, please share those, please help yourself. Okay, what you need to know about this is that since it's, sine of 2x instead of x, the period is, 2 pi over 2, which is just pi. Yes, it's gonna compress the graph, by a factor of 2. So it's gonna go from -1 to 1, and then 4, 3, so.
Wait, why is it compressing and not?
Because you could think of this as being inside parentheses, and that always has the opposite effect of what you want to say. Okay? So then it starts, the period is 5. So that's coming out here. So the minus does what? Flips it. And then it's really a plus 1, so that moves it up 1.
Don't use that big one.
What's that? Really think of it. Okay, so then last one, and we'll chat some more tomorrow. As Cameron and Caleb and I were discussing, the negative sign gets flipped upside down. And remember the period of this one would be back to 2 pi again, so technically negative sign would, start here, and then it would bottom out until pi over 2. And then come back to 0 again there, so it looks like this. So this is really gonna bottom to this is really off of the
Can you start your graphic?
of which one?
So one that's one.
Well, not that one. Not negative. You're gonna have to move it up 1.
Oh, I
Because
knew.
of the-
Okay, that's what I thought.
And so this point goes to here, and that one goes to here. So it's period of this one,
Is there a way-
regular old 2 pi.
Is there a way to rewrite that table as a program, basically?
No, because it doesn't go, I see what you're doing there, because it got moved up. But it doesn't go below the axis. The way you make it in the first one is by moving it to the left or to the right. Yeah, because this is, I'm doing a really bad job here because, we're trying to put it on the same graph. So after it passes pi, then it's gonna go up to 2 here.
Right, why is it not? Because this period, this one is 5, and this one is 2 times.
So really here's what's going on. If we do it the right way and redraw our scale to match to the 2 pi, okay? And then this is 1, and this is 2, and this is -1. The negative sign graph gets flipped upside down, so it looks like this. Oops. Terrible. Yeah, the negative sign.
Why is it going on?
Because now when I take this and move it up 1, because there's a plus
on the drawing.
The zero goes up to one, the negative one goes up to zero, this zero goes back up to one, but then this one goes to two. So then the graph looks like that. So we talked about last year in pre-calc was the idea of the sinusoidal axis, and so that the plus one there moves the sinusoidal axis from up and zero to